Hello and welcome to R&D Mathematics. Today we are going to talk about quadratic equations. Now, quadratic equation is an equation of this form: ax squared plus bx plus c equals 0. Now, we call this standard form. Now, for example, 7x squared minus 8x minus 16 equals 0. This is a quadratic equation. A is 7, b is negative 8, c is negative 16. How about this? 3x minus 5x squared equals negative 5. This is also a quadratic equation, but it's not in this form. So if we convert that into standard form, so the highest power term first, minus 5x squared plus 3x, and take in negative 5 to this side, left hand side, plus 5. So a is negative 5, b is 3, c is 5. So a quadratic equation in general, an equation where the highest power is 2. Now let's see how to solve quadratic equations. Actually there are 3 techniques. Let me write down techniques to solve. First one, factor in. Second one, square root method. Again, you don't have to memorize this. Third one, quadratic formula. You just have to have the idea. Actually, quadratic formula is coming from a general way of factoring, but it's really useful. With difficult numbers, you need quadratic formula. With easy numbers, you can factor it. Now, let's see some examples. Now, let's say x squared minus 6x minus 16 equals 0. Now, we have to find value of x that satisfies this equation. And also I forgot to tell you, so quadratic equation, there are 3 types of solutions. Now in my next video I will talk about this in general, why it will happen. So it can be 2 real roots or 2 real solutions or 1 real solution. Real means day-to-day numbers, and no real roots. This is the reason why we are using the word real, because when we have no real roots, we will have 2 complex solutions which are conjugate of each other. We will talk about this in general in our next video, but in this video, when you can solve it, the techniques involved in solving it. So first example, let's say this first example. Now you already knew how to factor this. We already learned how to factor something like this in one of our previous videos. Now this is an equation, but still your left hand side you can factor it. See, the general technique is, remember, ax squared plus bx plus c. You take a times c, that number, you find pairs that fits, and you can create p. In this one, negative 16. How you can get negative 16? 1 into 16, it doesn't work, and 2 into 8, it seems, using 2 and 8 I can get negative 6. So which combination will give you 2 into negative 8? So 2 into negative 8 is negative 16. 2 plus negative 8 is minus 6. So x minus 6x now can be replaced by minus 2x minus 8x minus 16. That was the technique I taught you in a previous video. Now you catch this part, x plus 2, and from these 2 I can take minus 8 out. Then you must get the same factor as here. Then from these 2 I can take x plus 2 out and x minus 8. So either x plus 2, see, at this point I have to explain something, When you have an equation like this, okay, in general, let's take another color. In general, if you have a times b equals 0, either a is going to be 0 or b is going to be 0 or both of them is 0. So using this simple fact, what we can say, either x plus 2 equals 0 or x minus 8 equals 0, which gives us x equal negative 8 or x equal 8. So negative 2 and 8 are our solution. So remember, another way is, when you easily understand this, when you see this equation, x is going to be, you can avoid these steps if you can, if you are good with simplification, x is going to be negative 2 and x is going to be positive 8. A common mistake students do just by looking at this, sometimes a common mistake is, in this example, a common mistake I have seen over time, student will just say x is 2 and x is negative 8 because here the negative sign and here the positive sign. No, it switches because you make it equal to 0. So x is going to be negative 2 and x is going to be positive 8. So this is the correct one. Now let's see another example. How about this? X squared plus x minus 20 equals 0. Now again, negative 20, you can break it. But if you can just see factors, x into x. So this is backward thinking. And I need to make negative 20. So here 1x. So I need 5 and 4. I can see that. And 1x, that's plus 1. So I plus here, minus here. So x is going to be 4 or x is going to be negative 5. See, if your simplification skills are good enough, you can directly do that. But I recommend, that's up to you. You judge yourself. If you want, let me go to the previous page. If you want more practice, you can do that. But, after practicing a lot, going through many problems, you can simply do it like this. Or if I do, let me show you. If I do it like this here, negative 20, you check for combinations. So 120, it doesn't work, 210, it doesn't work, and 4 and 5. It seems I can make number 1 using 4 and 5, and I did plus 1, so plus and minus. What you need to do then, x squared minus 4x plus 5x. So this 1x is replaced by minus 4x plus 5x minus 20. So the first two terms, you get x out, x minus 4. Second two terms, when you pull, let's see, 5 out, x minus 4. See, you must get the same factor here. Then when you pull x minus 4 out, you get x plus 5, giving us same thing as here. And thus x equal 4 or x equal negative 5, right? Now, how about this example? 2x squared minus 5x equals 0. Now, this is easy. You don't see any c term. So, a is 2, b is negative 5. In this case, you can simply factor it. So, x minus 5. So, here, x, see, you don't have any x plus or minus term. That means either x is going to be 0 or x is going to be 5. Wait a minute, I made a mistake here. So x here, it should be 2. So 2x minus 5, so x is going to be 5 over 2. Okay, now that's correct. Now, let me take this example. X squared minus 4 equals 0. Now, you can factor this. Difference between 2 squared. Can you remember that? A squared minus b squared equals a minus b into a plus b. So using that, x minus 2 into x plus 2. So our solution are going to be x equal 2 or x equal negative 2. Sometimes when this happens, we write it like this, plus or minus 2. Now, so you know what? This same example, this is factoring technique. This is factoring because we factored it. Same example can be done by square root technique. what you need to do, x squared equals 4. So I take 4 to the other side. So x is going to be square root of 4 with plus or minus, which is again 2. See, it works. Oh, this is helpful. Square root technique is helpful if the equation appeared like this. If your equation appeared like this, it's helpful because now x minus 3 is going to be square root of plus or minus 1. So two parts, x minus 3 either negative 1 or x minus 3 either positive 1. So x equal 3 minus 1, x equal 3 plus 1, which is 2 over 4, right? Now let's see the same example. Let me take the same example. So x minus 3 squared equal 1 to the next page. Let's see whether this has factors. In order to do that, so you have to expand this. So x squared, remember a plus b squared equal a squared plus 2ab plus b squared, or if you have minus here, you have to have minus here. So in this case, x squared minus 2 times 3 times x, which is 6x plus 9 equals 1. When I take 1 to the left hand side, I get 8 and 0, and I see factors 2 and 4, and I need to make minus 6, so I have to have both minus into minus, I get plus 8. Yes, so x equal 2 and x equal 4. And let me go to the previous page. See, 2 and 4. So any technique will work, but these are easy numbers. How about if you get difficult numbers? Then we have actually what is known as quadratic formula. Now, quadratic formula ax squared plus bx plus c equals 0. This one, x is going to be minus b plus or minus square root of b squared minus 4ac divided by 2a. Now, you must remember this because it's not easy to derive this. It's not easy to see why, because there is a lot of simplification. Now, where is this coming from? Falling from sky? Why? Well, that's in my next video. But in this video, let's believe this, let's agree with this, and let's use this. So let's see some examples. Let's see some examples. About some numbers, difficult numbers. So negative 2x squared plus 3x plus 5 equals 0. Now, you don't see factors that easily. Well, of course, you can factor these with some fractions. So your factor is going to look like 2x minus 5, something like that. But anyway, factoring is, in general, it can be difficult. So in that case, you can use quadratic formula. A is negative 2, b is 3, and c is 5. So your x is going to be negative b. So negative 3 plus or minus b squared. So 3 squared minus 4 times a negative 2 times c5 divided by 2a, so 2 times negative 2. So when we simplify negative 3 plus or minus, we have 9 plus 4 into 2, negative into negative positive, so 9 plus 8 into 5, 40, divided by negative 4. So we have negative 3 plus or minus 49 square root. Well, 49 is 7 squared, which is nice. So we have negative 3 plus or minus 7 divided by 4. So at this point, we can break this into 2. X is going to be the negative 3 minus 7 over 4, or x is going to be negative 3 plus 7 over 4. So negative 10 over 4 O, which is negative 5 over 2. That's one solution. See, exactly as I thought, it's going to be fractions. And 7 minus 3, 4, 4 over 4, which is 1. Now, let's see, let's go to the previous page. I told you at the beginning, quadratic formula can be used for any quadratic equation. So because of that, mostly students like to memorize it and use it. But sometimes factoring, when you can easily factor it, factoring is easier. So let me go to the previous. Okay, how about this? Let me use a different color. In this example, A is 1, B is negative, B is 0, you don't see x term, C is negative 4. So x is going to be negative B, let me recall you, so negative B plus or minus B squared minus 4AC divided by 2A. So negative B 0 plus or minus B squared 0, it's gone, minus, that minus is in our equation, 4, that's in our equation. A is 1, C is negative 4. Divided by 2. Negative 4 into negative 4, 16. Plus or minus, divided by 2. So square root of 16 is 4. When you divide this, plus 4 divided by 2, that's 2. Minus 4 divided by negative 2. Same solutions here. See? Not that, sorry. Here. And let's see our previous example. Well, again, in this case, C is 0. Let me... Yeah, how about this? Well, this example, let's try to do it here, over here, in this little space. Let me erase this. So, using quadratic formula, x is going to be minus b, b is 1, so minus 1, negative 1, plus or minus b squared, 1 squared, minus 4 times a times c, a is 1, c is negative 20, divide by 2a, 2 times 1, which is 2. So minus 1 plus or minus 1 minus into minus, we have plus 80, 2. So minus 1 plus or minus 81, square root of 81, which is nice because it's 9. So you break it into 2, minus 1 plus 9 over 2, or minus 1 minus 9 over 2. So 9 minus 1, 8 over 2, 4. See this solution. And negative 10 here, and over 2, negative 5. See this solution. So quadratic formula can be used for any quadratic equation. So these are the 3 techniques, guys. But all those examples, how about this? I'm not going to solve this, but I'm just picking these numbers random. I want to show you something here. I recommend you writing down these numbers, because see, this is when your b is negative, again a common mistake students make. So my quadratic equation formula, negative b plus or minus b squared minus 4ac divided by 2a. See, as your teacher, I need to address common mistakes. Now negative b already negative, so negative b, so it's positive 7, plus or minus. See, one common mistake is right here. When you write here, students tends to write just negative 7. No, it's negative 7. Negative is this negative that's in the equation, and then your b itself is negative. And the next mistake that can happen when your b is negative, negative 7 squared, they write it like that. No, that's wrong. Put parentheses. That's going to be, again, positive. 4 times a is 3, c is negative 15 over 2a, which is 3. Okay, I think I addressed that common mistake. Now, those are the 3 techniques of solving a quadratic equation. Now, in my next video, I'm going to tell you, I'm going to do what's known as discriminant. And when I'm explaining that, I will explain how we get this formula. Okay, see you in next video. Thank you.